Hello everyone, my name is Suresh Kumar. I want to explain about two-level clippers in this class in the subject called digital electronics. Actually, in the last class, I explained about two-level clippers by taking one gate question. But in this class, I want to explain all kinds of two-level clippers. Suppose I taken a circuit like this. In this circuit, there are two diodes D1 and D2 and two reference voltages VR1 and VR2. By keeping the positions of diode D1 and D2 and by varying the VR1 and VR2, we can get four different circuits from this basic diagram. Suppose D1 D2 are fixed. We can make VR1 and VR2 both in positive or both in negative, or VR1 is positive and VR2 is negative and vice versa. That means VR1 is negative and VR2 is positive. In this manner, we can arrange the same circuit in four different styles. I want to explain a simple procedure for analyzing any kind of two-level clipper. Suppose I taken the first case, that is for diode D1 I connected positive VR1 and for diode D2 I connected negative VR2. So what will be the output we have to find. For getting the output, I am taking the graph like this. Initially I am considering a graph having x-axis and y-axis. On x-axis we will take time, on y-axis I am representing output waveform V0. Here I have to plot the output. For reference purpose, I will consider input waveform on the same graph by plotting with dotted lines like this. I always consider sine wave as input. Why? Because it is a standard waveform. So by considering the sine wave, we can analyze the circuit in an easy manner. So the first step is we have to consider the input waveform in dotted lines on output graph. Next, we have to represent the reference voltages with the dotted line on the graph. See, VR1 is positive and VR2 is negative. So on positive side, I will write one fixed voltage and I will represent as VR1. On negative side, I will represent one line and name it with minus VR2. See, these two reference voltages and this input waveform all are for reference purpose only. My main aim is I have to plot the output waveform on this graph. For that, initially I have to consider different cases from this graph, and after that I have to apply those conditions for the circuit and I will get easily what will be the output. So the first step is, from the waveform we can consider initially our input is 0, that is the input lies between reference voltages VR1 and minus VR2. So the same condition can be represented mathematically like this: V in is greater than minus VR2 and V in is less than VR1. So this is the condition I written by using the waveform. Now I am applying the condition to the circuit. Suppose V in is greater than minus VR2. That means the case we can represent here. The cathode voltage is greater compared to anode voltage. From the first class, we discussed about forward bias and reverse bias conditions. When cathode voltage is high compared to anode voltage, then the diode enters into reverse bias and acts like open circuit. So from this condition, we can write D2 is off. Next, V in is less than VR1. If we apply same condition here, the anode voltage is less compared to cathode voltage. So this diode also enter into reverse bias and acts like open circuit. That means D1 also off. So from this we can say that both diodes are open circuited. That means there is no effect of reference voltages on output. So the input as it is will appear at the output. So from these conditions, output becomes input. If you observe carefully in this output graph, at this curve and at this curve and at this curve, the condition is same. That means our input lies between both the reference voltages VR1 and minus VR2. So this condition will applicable at this. So I can join the dotted lines like this. So this thick line indicates the output waveform. Dotted lines are for reference purpose only. The thick line is the actual output. So one condition completed. The second case is in this portion our input, this dotted line sine wave is our input. This input is greater compared to both VR1 and minus VR2. So I'm writing the same condition here. The second case is V in is greater compared to VR1 and also V in greater compared to minus VR2. So if we apply same conditions in the circuit, what happens when V in greater than VR1? That means anode voltage is greater compared to cathode voltage. Then diode D1 will enter into forward bias and acts like short circuit. Simply we can say that it is on. Whereas in the case of second diode, V in greater compared to minus VR2. That means cathode voltage is higher compared to anode voltage. So diode D2 enters into reverse bias and acts like open circuit. So simply we can say that diode D2 is off. From these two we can say that when diode D1 is short circuited, this reference voltage VR1 will appear at the output. So output is simply VR1. So I can represent this VR1 in the graph like this. From this point to this point, the output wave is just simply VR1. The third case is from this curve we can say that our input is less than compared to both reference voltage and minus reference voltage. So we can write like this: V in is less than compared to VR1 and V in is less than compared to minus VR2. If we apply same condition in the circuit, what happens? V in is less than compared to VR1. That means anode voltage is less compared to cathode voltage. So diode D1 will enter into reverse bias and acts like open circuit. Simply we can say that D1 is off. Next, V in is less than minus VR2. That means the cathode voltage is less compared to anode voltage. Here cut-in voltage we can assume as 0 volts. Why? Because in general silicon diode cut-in voltage is 0.7 volts, which is very small, we can neglect. But in the question, if we specifically mentioned the cut-in voltage, then we have to consider that voltage. Now, since the cathode voltage is small compared to anode voltage, this diode D2 will enter into forward bias. Observe carefully. Here both the terminals are connected to negative supply only. Even though both the terminals are connected to negative polarity, this diode will enter into forward bias, because the definition says that when anode voltage is greater compared to cathode voltage, diode will be forward bias. So simply D2 is on. From this we can say that since diode D2 is on, short circuited, this reference voltage VR2 will directly connected to the output. So output is simply minus VR2. So we can represent same thing here like this. So in this manner we can plot the output waveform for any kind of two-level clippers. In the next class I will complete all kinds of two-level clippers. This is the procedure we have to follow in each and every case. If you have any doubts in this procedure, please comment and I will answer. Thank you.